Cambridge IGCSE, May-June 2021, Paper 43. Question 1. Figure 1.1 shows a load suspended from a spring. The value of the spring constant K of the spring is 0.20 Newton per centimeter. The spring reaches its limit of proportionality when the load is 15 Newton. Calculate the extension of the spring when the load is 3 Newton. So in this question, the spring constant of the spring is given, that is represented by the letter K, and we need to calculate what is the extension when the force is 3 Newton. So here we can use Hooke's law equation, that is force applied is equal to Kx, where K is spring constant and X is extension. In this question, force is given, which is 3 Newton, and spring constant K is also given. In order to calculate X, we can make X the subject. So we will get extension X is equal to force over spring constant. So the force is 3 Newton over spring constant is 0.20, and the answer is 15 centimeter. So we can write extension 15 centimeter. Part B. Explain what is meant by the term limit of proportionality of the spring. We can explain limit of proportionality with the help of Hooke's law. In Hooke's law, it states that force is directly proportional to extension, or extension is directly proportional to the applied load or force, but only up to the limit of proportionality. After that, the spring will not obey this relation. Therefore, we can write extension of a spring is proportional to the load only up to the limit of proportionality. This is a 2-mark question. So first mark you will get for writing extension of a spring is proportional to the load, and the second mark is for writing up to the limit of proportionality. Question C. On figure 1.2, sketch an extension load graph for a spring. Label the limit of proportionality with the letter L on the graph. So here we need to draw an extension load graph. We have to be careful on y-axis which physical quantity we have to plot. In this question, on y-axis extension is given and on x-axis it's load. But some questions on the axes opposite quantities will be given. That is, on y-axis instead of extension load, and on x-axis instead of load extension will be given. So that in such cases the shape of the graph will be different. So it's very important to check which quantity is given in x and y axis. So when we plot the graph, as load and extensions are directly proportional, it should be straight line starting from origin. Then after limit of proportionality, the line won't be straight as it does not obey Hooke's law. Then it will extend bit upwards, or gradient will start to increase. And in the question it's mentioned that we need to label the limit of proportionality with the letter L on your graph. So the point where it stopped the relation of directly proportional, where we have to mark as L. This is the limit of proportionality. After that, it won't be a straight line. Part D. The load is pulled down a small distance below its equilibrium position to position A. As shown in figure 1.3, the load is then moves up and down between position A and B in figure 1.3. Describe the energy transfers which occurs at the load moves. So initially the load is pulled down a small distance below its equilibrium position to position A. Later on, the load then moves up and down between position A and B. So from this we can understand that this load is moving or oscillating up and down. It's keep oscillating, moving up and down, and the equilibrium position of the load, that is when there is no movement happening to the spring or the load, it will stay at rest, and that will be exactly at the center between the positions A and B. So these blue dotted lines represent equilibrium position. And when we extend this load is moving from A to B, and it's keep oscillating in between these 2 points A and B. This is what happening in this particular case. We need to describe the energy transfers which occurs as the loads moves between A and B. Now we can check each position. At each position, what kind of energy this load will have. So initially we can look at position A. At position A, we can see the spring has extended maximum, so that it will have an elastic energy or elastic or strain energy at position A. When it moves from A to equilibrium position, that means movement from position A to equilibrium, at position A, actually the load stops and it's going back. So at position A, the speed or the velocity or the speed of load will be 0. But when it is moving upward and when it reaches at the equilibrium position, it will have a maximum speed. For any object which oscillates in between 2 points, it will have a maximum speed at its equilibrium position. So from this we can understand speed of the load will be maximum at equilibrium position. Therefore, its energy will be in the form of kinetic energy. As speed is maximum, kinetic energy will be maximum, because kinetic energy is the energy associated with the speed. So the load which will have a maximum speed at the equilibrium position, its energy will be converted from elastic energy to kinetic energy at the equilibrium position. Now we can see what will happen to the load when it's moving from equilibrium position to position B. When the load is at position B, we can see that the load is at a maximum height from the ground. So when the height or the position of the load increases, its energy will be in the form of gravitational potential energy. Therefore, we can conclude that at position B, its energy will be in the form of gravitational potential energy. Therefore, we can write from position A to equilibrium position, when this load moves, we have already seen at position A, elastic energy, and at equilibrium position, it's converted to kinetic energy. So we can write changing from elastic energy to kinetic energy. And from the equilibrium position to position B. So at equilibrium position, speed is maximum. At position B, height from the ground is maximum. So we can write from kinetic energy to, at equilibrium position, the load will have a maximum kinetic energy. So this kinetic energy to gravitational potential energy at B It's because at B, the height from the ground is maximum, and when the height increases, the gravitational potential energy increases. You should mention from which energy to which energy. So from elastic energy to kinetic energy. Likewise, from kinetic energy to gravitational potential energy. So you'll get 3 marks. Question 2, Part A. Figure 2.1 shows a bookshelf with 2 groups of books A and B on it. There are 6 books in each group of books. All the books are identical. The mass of each book is 0.52 kilogram. Part 1. Explain why the pressure exerted on the shelf by books in group B is less than the pressure exerted on the shelf by the books in group A. In order to answer this question, we can look at the equation of pressure. Pressure exerted on the shelf by the books is equal to the force of these books, force or weight, over the area in which the books are in contact with the bookshelf. And for both the sets of books, the force or the weight is same. As it's mentioned, there are 6 books in each group and all the books are identical. So the force is same for both set of books. Now we can look at the area in contact with the shelf. So when we are looking at the group B of books, the area of contact is equal to this area, or the same area will be in contact with the bookshelf at the bottom. But for group A, area of contact only less, only this much. So we can understand for group B of books, the area is more. So for group B, as the area is more, the value at the denominator is greater, so that the pressure will be less. So this is the reason it mentioned in the question that the books in group B is acting a less pressure comparing to the books in group A. Since it is a 3-mark question, we need to write 3 points. So first we can start with the equation of pressure. So we can write pressure is equal to force over area. And we can mention about the force and area separately. First we can mention about the force. And we have already seen that the force exerted by each groups of books are same. So we can start where force exerted by each groups of books are same. So numerator is same. Now we can look at the denominator, that is the area. Area which is in contact with bookshelf in group B is greater. So we can write area in group B is greater than group A. Even you can mention that area in contact with the bookshelf. This is a 3-mark question. So first mark you will get for writing this equation of pressure. Second mark is for writing about the force, as force is same for both sets of books. And the third mark belongs to mention about the area which is greater for group B. Part 2. Calculate the pressure exerted on the shelf by the books in group A. So we can look at the group A books. First we can write the equation. Pressure is force over area, where here the force is nothing but the weight of these 6 books in group A over the area which is in contact with the shelf. So first we can calculate the weight, where weight is not given directly, but it's given that the mass of each book is 0.52. So we can first calculate what will be the weight of 6 books. So weight is equal to mg. So weight of one book is 0.52 times g is gravitational constant, which is 10. So we will get 5.2. But this is the weight of one book. So we can find the weight of 6 books. That will be 6 times weight of one book, that is 5.2. So we will get 31.2 Newton. Now we have the weight, that is 31.2. We can substitute in our main equation over area. We can look at the area where we are provided with the length and breadth, where length of these 6 sets of book is 1.3 centimeter times 6, because only the thickness of one book is given. So the total thickness of 6 such books you have to multiply 1.3 times 6. So that we can consider as the length, and breadth is already given, that is 21 centimeter. So the area will be length times breadth. So we can substitute here. Area is length times breadth. So 31.2, that is the weighted numerator, over length is 1.3 centimeter times 6, because the thickness of one book is 1.3 centimeter. Centimeter we need to convert into meter. This is the thickness of one book. So for 6 books you have to multiply with 6. So this is the length, which you should multiply with breadth, which is also given, that is 21 centimeter. So this is, you should multiply with 21 centimeter. You should convert again into 10 to the power minus 2. This is a conversion of centimeter to meter. And we will get the answer 1900. So we can write 1900. The unit of pressure is Pascal. This is a 3-mark question where 1 mark you will get for showing this working for the calculation of weight. And the 2nd mark is for finding the area. You should show this working, then only you will get the 2nd mark. And the final mark is for the answer, which should be into SF with the unit. Part B. A diver dives to a depth below the surface of the sea where the total pressure is 3 into 10 to the power 5 Pascal. The atmospheric pressure is 1 into 10 to the power 5 Pascal. The density of the sea water is 1030 kilogram per meter cube. Calculate the depth of the diver below the surface of the sea. Here we can use the equation of the pressure in fluid, that is pressure is equal to rho gh, density times gravitational field strength times height or depth. So the diver dives below the surface of the sea. So when we consider the sea, at particular depth below the surface of the sea, the diver stays at this position where the total pressure is given. This is very important, that in the question the total pressure at this depth is given, that is 3 into 10 to the power 5. But out of this total pressure, the atmospheric pressure is 1 into 10 to the power 5. So the remaining pressure will be the pressure due to the seawater. That means the total pressure at this point is 3 times 10 to the power 5 Pascal. But out of this total pressure, 1 into 10 to the power 5 Pascal is due to the atmospheric pressure. So at this point, the pressure due to the liquid, in order to calculate, or the pressure due to the seawater, we will have to subtract the total pressure minus the pressure due to the atmosphere. Then only we will get the pressure due to seawater. So we can calculate that first. Pressure due to seawater will be the total pressure at this depth. That is the total pressure, means the pressure of the seawater plus atmospheric pressure. So that is 3 into 10 to the power 5 minus the atmospheric pressure. So we will get 2. This is the pressure due to sea water, and G value we know that 10, and height is nothing but depth, which we need to calculate, and density of the seawater is also given, that is 1030 kg per meter cube. So in our equation the pressure is already given, which we calculated by subtracting the total pressure and the atmospheric pressure, and the density of the seawater is also given. G is the gravitational constant. Therefore we can calculate H, or the depth. In order to calculate H, we can make H as the subject. So we will get height is equal to pressure over rho G. Now we can substitute the values. So the pressure due to the seawater is 2 times 10 to the power 5 over density of the seawater is 1010 times G is 10. And the answer into SF is 19. Unit of depth is meter. So we can write 19 meter. Question 3. A car travels at constant speed V on a horizontal straight road. The driver sees an obstacle on the road ahead. Part A. The distance travelled in the time between the driver seeing the obstruction and applying the brakes is the thinking distance. Explain why the thinking distance is directly proportional to speed v. So here we have a car which is traveling at a constant speed on a horizontal straight road, and the driver sees an obstacle on the road ahead. So we can see here is the obstacle. So the driver sees the obstacles at this point. We can imagine at this point when the driver reaches, he sees the obstacles ahead. So when he sees the obstacles, he will apply brake in order to stop the car. But for this thinking purpose, he will take some time. So we can imagine after seeing the obstacles to realize that there is an obstacle, so he should stop the car and then he will apply the brake. So for this we can think this much time he has taken. So when the car has reached at this particular point, only the driver applied the brake. Therefore this distance we can call as thinking distance, because he has taken some time between seeing the obstacle and to apply brake. Now we need to explain this thinking distance, that is this distance is directly proportional to the speed of the car. So here we can check the relation or equation between the distance and the speed, and we know that speed is nothing but distance over time, and here the time is taken by the driver to think. So we know that the thinking time, or in order to think about the realize that there is an obstacle, so I should stop the car, so I should apply brake, that will be always constant. Doesn't matter how slowly or how fastly he was driving, the thinking time will be always same or constant. It is completely depending on the driver. So we can understand the time or the thinking time here is a constant value. As it is constant, or as the thinking time is constant, when the speed increases, the RHS of the equation will also increase. That means the distance will increase. Or all remaining thing, that is time is constant, so definitely speed will be directly proportional to the distance or thinking distance. Therefore, in order to answer this question, explain why the thinking distance is directly proportional to speed, we can write thinking time is constant. Since it is 1 mark question, this statement is enough. Part B. When the brakes are applied, the car decelerates uniformly to rest. The frictional force applied by the brakes is constant. The distance travelled between first applying the brakes and the car stopping is a braking distance. Explain why the braking distance is proportional to v square. So here the car initially was moving with a constant speed. We know that it's mentioned in first part. So when the car is moving with a constant speed v, it will have an energy in the form of kinetic energy, and its kinetic energy while it is moving is half mv square. But once the driver sees the obstacle, when he moves forward, he will apply a brake at particular point. So after this point, or when he applies the brake, the car will do some work against the friction in order to stop the car. So the car will use all its kinetic energy in order to work against friction. Then only the driver can stop the car. So here we can understand all the kinetic energy the car had will be using in order to do some work against the friction. So that is the first point we can write down, that all the kinetic energy of the car will be used to do the work against friction. So we can write down kinetic energy of the car, which is in bracket you can mention half mv square, will use or will consumed to do work against friction in order to stop the car. So same statement we can write in terms of equation, that the kinetic energy of the car, which was half mv square, will be converted to the work done against friction, and the equation of work done is force into distance, where here the force is nothing but the frictional force times the distance, or braking distance. We can denote it with the letter D. Now when we look at this relation, we can understand half mass and frictional force. These all are constant. Mass of the car is constant. Frictional force of the road is also constant. From this we can conclude that the stopping distance t is directly proportional to the square of the speed of the car, or v square. This is a 3-mark question. 1 mark you will get when you write the word kinetic energy, or when you mention the kinetic energy of the car. Then writing the equation, which is half mv square, you will get next 1 mark, will be used to do work against friction. And for writing this relation, you will get the next 1 mark. Part C, the car is traveling at speed 22 meter per second. The thinking distance is also given. Calculate the time taken to travel the thinking distance. So you just need to calculate the time for the same distance. So here we can use the equation speed is equal to distance over time. And in order to calculate time, you can make time as the subject. So we will get time is equal to distance over speed, where the distance is 15 meter over speed is 22 meter per second, and the answer is 0.68 seconds. So 0.68 second is the correct answer. Part 2, the car has a mass of 1400 kilogram. The time taken for the car to stop after the brakes are applied is 2.1 second. Calculate the force required to stop the car in this time. So here we need to calculate the force, the time and mass already given. So here we can use the equation, that is impulse is equal to change in momentum, where impulse is the product of force and time, is equal to change in momentum, that is mv minus mu. From this we can get force is equal to mv minus mu over t, or you can use this equation directly, that is force is rate of change of momentum. So if you use this equation directly also, you can score the mark. Now we can substitute, where mass is 1400 times initial velocity of the car, that is already given 22. So we can write that is 22 minus again mass times the final velocity. The final velocity of the car is 0, since the car stops. When the driver sees the obstacle, he applies brake, so the car will stop. So the final velocity will be 0. Yeah, there is a correction here. The final velocity should be 0, that is mv should be 0, and mu is the initial velocity, which is 22. Over time is already given in the question, 2.1. So we will get 0 minus 1400 into 22. Or you can directly calculate, and the answer is 15,000 Newton. When we do the calculation, we will get a value that is 14,666, but when you write into SF, we can write 15,000 Newton. Question 4. Define specific latent heat of fusion. This definition is very important. You can see in so many past papers, so you have to study the definition. And latent heat of fusion is nothing but if you have 1 kilogram of a solid substance. So here a very important point is the solid substance should be 1 kilogram. Then in order to convert this solid completely into liquid. How much energy we need to, or how much heat energy we need to supply to this system? So the heat energy required or energy required to convert 1 kilogram of solid into liquid is known as latent heat of fusion. Therefore we can write it is the energy required or energy transferred when 1 kilogram of a solid substance melts to form a liquid. So this much is enough, this point. Where the important keyword you should mention, it's 1 kg and energy transferred in order to melt. Melts means converting from solid to liquid. These two are very important keywords in order to score 2 marks. Part 2. A cup of water contains 250 centimeter cube of water at a temperature of 0 degrees Celsius. An identical cup contains 250 centimeter cube of a mixture of ice and water at a temperature of 0 degree. The temperature of the surrounding air is 20 degree Celsius. State and explain which cup contains the liquid with the lower temperature after 10 minutes. So in this question we have two identical cups. Two identical cups mean they have all same kind of thermal properties. They made with same material, same thickness, everything is same. And in first cup it contains 250 centimeter cube of water. So the first cup contains 250 centimeter cube of water. And the temperature of this water is 0 degrees Celsius. And in the second cup, again there is a 250 centimeter cube of mixture of ice and water. So in the second cup, as you can see, even though it has same volume of the substance as in first cup, in the second cup it's not completely water, but it is a combination of ice and water. And we need to check. We need to state and explain which cup contains the liquid with lower temperature after 10 minutes. So we can see after 10 minutes what happens. And there is very important point given in the question that the temperature of the surrounding air is 20 degrees Celsius. So at the surroundings there is a higher temperature, that is 20 degree, and the substance in both the cups are having a temperature of 0 degrees Celsius. Now let us see after 20 minutes. If you keep these cups, we can see what will happen. The temperature from the surrounding, that is 20 degree, will be absorbed by both the substances or substances in both the cup. And when we look at first cup, we can see it was 0 degrees Celsius but all in liquid form. So then this cup will, or this liquid in the cup will absorb the temperature from outside in order to rise its temperature. So temperature will increase easily. But when you look at the cup C, there are some ice cubes. So these ice cubes will absorb the 20 degrees Celsius atmospheric temperature simply to change its states from solid to liquid. So that is the important point we should notice inside the second cup. As there are so many ice, these ice will absorb 20 degree Celsius temperature from outside, not to increase its temperature from 0 degree to something greater, but simply to convert its state from solid to liquid. So when you look at the temperature, both ice cubes, initially it was at 0 degrees Celsius, but just after converting to liquid, even though it absorbed some temperature from outside, still as it used all its temperature 20 degree from the atmosphere is only to convert its state, this liquid will still remain as 0 degree for some time. So for cup 1, it will easily increase its temperature as it absorbs the temperature from outside and directly increasing its temperature. But for liquid in cup 2, as it uses some of the atmospheric temperature just to change the state from of ice to liquid, it won't increase its temperature as quickly as cup 1. Its increment in temperature will be a slow process. Therefore, we can say as which cup contains liquid with lower temperature after 10 minutes. Definitely it will be cup B, as cup B takes some of the temperature just to convert from solid to liquid. So we can write which cup, that is the cup containing mixture of ice and water. And we need to write the explanation. We can write mixture of ice and water will remain at 0 degree for more time until all the ice melts. But temperature of water at 0 degree directly increases as there is no ice in the first cup. But these many points are enough since it is only 2-mark question. Going to part B. On a hot day, sweat forms on a person's skin and then evaporates. Explain in terms of molecules how the evaporation of sweat cools the person. So here we need to explain the process of evaporation, how the energy takes during evaporation and how it will result. So we can explain the process of evaporation. So we can write in evaporation, more energetic molecules, that means the molecules with high kinetic energy, they will always present at the surface of the liquid. So I will just explain the process of evaporation. If you have a container with some liquid in it and if it doesn't have a lid, we can see the container is open and there will be water molecules. The water is, or this liquid is made up of liquid molecules, and the molecules with high energy will always reside or stay at the surface of the liquid. So when you compare the molecules of liquid at bottom, they will have always less energy. But when the molecules gain more and more kinetic energy or simply energy, they will move upwards. Therefore, always the molecules with high kinetic energy will come to the top of the liquid surface. So this is the first point we need to write. In the process of evaporation, more energetic molecules, they always stays at the surface of the liquid, will escape. So these high energetic molecules, they are at the surface, they will escape from the liquid surface. So in first statement we can write in evaporation, more energetic molecules escape from the surface of the liquid. So we have already seen that. So when we looking at the liquid, we can understand high energetic molecules already escape from the liquid. So in the liquid only the molecules with less energy are remaining. Therefore we can write down, as high energy molecules escaped, lower energy molecules remain in the liquid. Now again we can look at the figure. We have seen some of the molecules, they have higher energy, so they escaped. But from where they gain this energy? Actually these molecules absorb the energy from the person in the form of thermal energy. So these escaped molecules, basically they absorb the thermal energy from person. Therefore their temperature or energy increased. That's why they could escape from the liquid surface. So for this process, these high energy molecules actually gain energy simply by taking the energy or thermal energy from the person's hand. So that is the point we can write next. So we can write down, thermal energy is taken from the person by the high energy molecules to escape from the liquid surface. Therefore the person loses some of his thermal energy so that he will cools down. So the person cools down. Part 2. Explain why this process is more effective when a wind is blowing. So we just need to explain if there is a wind, how the evaporation process will be more effective. So if there is a wind, the process of evaporation rate will increase. So we can write faster evaporation of sweat as wind blows fast moving molecules away. This means from the surface of the skin, suppose this is skin, and there is sweat on the skin, and we have already seen as the process of evaporation, high energy sweat molecules will escape from the sweat and it will escape to the surrounding. Now if there is wind, what will happen? The wind will blow all these molecules away from the liquid surface. So there will be more vacant place, so more molecules will absorb energy from person's hand and again they will escape, so that the evaporation process will increase. This is the reason. Question 5, part A. Figure 5.1 shows a wave on the sea approaching a harbor. Part 1. On figure 5.1, draw 3 wave crests in the harbor. So here we can see when the water waves pass through a small gap, diffraction will happen. Diffraction is nothing but bending of waves when they pass through gaps. So after passing the gap, you should draw the water waves, but that should be not straight. So we can draw 3 wave fronts that should be bented. So these are the 3 wave fronts you have to draw. Part of circles, all should be centered to the center of the gap. We should draw minimum 3 wave front in order to score full mark. And another very important thing you have to be careful is about the wavelength, that you should take a ruler and measure this length. Actually that is the wavelength lambda. Even after the diffraction or after passing through the gap, this length must be still same. The wavelength of the wave will not change even after diffraction. So you have to be careful to check this length and draw. That is also important. Part 2. Another harbor has a much wider gap between its walls. Describe and explain how the pattern of wave crest in this harbor is different from the pattern you have drawn. So in the second scenario, the gap width is more wider. In this case, what will happen to the amount of diffraction? This is what we need to know in order to answer this question. Amount of diffraction depends on the wavelength of the wave compared to the size of the gap. So we can check the first case where the gap width is greater than the wavelength. That is the same case mentioned in part 2 here in the question, where the gap width increased. So comparing to the wavelength, the gap width is greater. In this case, amount of diffraction will be very less, or there won't be no diffraction occur. So this is the same case asked in this part of the question, where the gap width is greater or increased. Next possible case is when the gap width is equal to the wavelength of the wave. Then the most diffraction will occur in this condition. And the third possible case is the gap width is much smaller than the wavelength. So in this case, most of the waves will reflect back. They won't be able to pass through this small gap. So most of the waves will be reflected back as the gap size is too small. Therefore, now we can answer this part, that when the gap width is increases or wider, that is an example of first case. We can write very less diffraction occurs. Or no diffraction occurs. Sorry, this must be the point we should write for the explanation, because this question has two parts. Description, that is what is the observation or what will be the pattern of the wave, that should be written in the space given for description. So as there is no diffraction or very less diffraction, even though the waves passing after the gaps, it will still remain as the straight waves. Therefore we can write waves pass through gap remaining straight. Part B, a sound wave of frequency 850 Hz travels through sea water. The speed of sound in water is 1500 meters per second. Calculate the wavelength of this sound wave in sea water. So we have a sound wave of frequency 850 Hz travels through the sea water, and the sound wave speed is also given. We need to calculate the wavelength lambda. So we can use the wave equation, that is speed of a wave equation is the product of frequency and lambda. We can substitute the values which is given, that is speed is 1500 is equal to frequency 850 times wavelength, which is not given. So in order to calculate the unknown value lambda or wavelength, we can make the wavelength as a subject. So we will get lambda is equal to 1500 over 850, and the answer is 1.8 meter. When you calculate, you will get 1.76, but we should write the answer in two significant figure. So we can write 1.8 meter. Please make sure to write the equation and the working part in order to score full mark. Question 6, figure 6.1 is a full scale diagram of a lens and an object O. Part A, the focal length of the lens is 3.5 centimeter. On figure 6.1, mark and label with the letter F the positions of the two principal focuses. So in this part, it's already mentioned that principal focuses is 3.5 centimeter away. So you need a real question paper and take a ruler and measure 3.5 centimeter from the center of the length at both sides of the lens. So you have to take and measure 3.5 centimeter from the lens to the right side and mark that point, and that will be principal focus F. Likewise, we need to find the principal focus on the other side. So again you have to take the ruler and measure 3.5 centimeter away from the center and mark the another principal focus. So this length should be 3.5 centimeter at both the sides, and you should take a ruler and measure and mark it. As I am not using a real paper, I cannot use the ruler here, so I am just doing a rough diagram. But please make sure when you are doing, you should have the real paper and take the ruler and take the exact measurement, that should be 3.5 centimeter away from the center of the lens. Part B, on figure 6.1, draw 3 rays to locate the image. Draw an arrow to represent the image and label the image I. So here we can see the object has placed after the principal focus, or the distance between object and the center of the lens is even greater than 3.5. From this we can understand the object has kept behind the principal focus. So in this case, what will be the position of the image? In order to know that, we need to draw 3 rays emerging from the object. You should draw this figure with a ruler and a pencil. First we can draw a ray which is emerging from the object and which should be parallel to the principal axis. So that should be a ray which must be parallel to the principal axis. So it will go parallel, it must be straight, and when it reaches at the center of the lens, since it is parallel to the principal axis. After passing through the lens, it will pass through the principal focus at the next side of the lens. So again, take a ruler and pencil and draw a line which should be passing through the principal focus, and make sure it's a straight line. Next, we can draw a ray which is emerging from the object but passing through the principal focus. So when it is passing through the principal focus, these rays, when they reaches at the lens, they will move parallel to the principal axis at the other side. So these lines will be parallel after passing through the lens, as they are passing through the principal focus. After passing through the lens, they will follow a parallel path to the principal axis. So this is the third ray, and this is the second ray we have drawn. We can put the arrows also. Now we can draw the third ray. The third ray, that should be passing through the lens center, so that such lines will not bend or diffract. It will pass in the same straight path. So that is the third ray we can draw. As this ray is passing through the center of the lens, there won't be no deviation, but it will keep moving in the straight path. So this must be the direction of the third ray. Now we can see these three rays are meeting at a point at the right side of the lens, and where we will get the image. So this is the image formed, and we need to label I. That is mentioned in the question. And you should not forget to put the arrow to indicate the direction of the image or the position of the image. It will be an inverted one. Part C, state three properties of the image I. So we need to mention three properties of this image formed. By looking at the diagram, it is clear that the image is inverted and enlarged. So we can write that is the first point. Enlarged means size of the image is larger than the size of the object. That's why we are getting a magnified image or enlarged one. And this image is actually formed by real rays. So the image is real. So that is the second point you should write in order to score full mark. So the image is real. Part D, a student incorrectly states that this lens is being used as a magnifying glass. State how the image produced by a magnifying glass is different from the image I. In order to answer this question, we need to know the properties of image formed by a magnifying glass. So the image produced by a magnetic glass is actually, it must be upright. But here we are getting an inverted image. And the second property of an image formed by a magnifying glass, that it will be a virtual image, not real. But in the case of the lens given in this particular question, that is a image we got, that was a real image. But actually in a magnifying glass, it will be a virtual image. So we should mention these 2 points in part 1 in order to state how the image produced by magnifying glass is different from the image I. Image produced by a magnifying glass is upright and virtual. Part 2, the student moves the object O to a position P so that the lens showing in figure 6.1 act as a magnifying glass. On figure 6.1, mark a possible position for P. So here the student should change the position of the object from here to some other position in order to get a image which should have all the properties similar like the image we are getting from a magnifying glass. That means the image formed should be upright and virtual. So we should check where we must keep this object in order to get an image which must be upright and virtual. and enlarged one also. So you must be familiar with all different possible positions of the object and the image formed in all cases. Then only you can answer this question. So in order to get an image which must be enlarged, upright and virtual. In order to get an image like that, we should keep the object between the principal focus and the lens. So the object position, new position should be like this, and we need to mark it as P as mentioned in the question. So if you place the object here, you will get an image with these properties, so which are similar like a magnifying glass. Question 7 part A, define electromotive force. This is a very important definition. According to the definition, electromotive force is the energy required to drive 1 coulomb charge round a complete circuit. If it is a EMF, you should mention a complete circuit. So energy required is a very important keyword, and in order to drive 1 coulomb charge round a complete circuit is the another keyword. If you have written these 2 points only, you can score 2 marks. Part B, figure 7.1 shows a circuit. The 2 lamps shown are identical. Each lamp has a potential difference of 3 volt across it and a current of 2 ampere in it. PQ is a length of uniform metal wire. The resistance of PQ is R. Calculate the value of R. So in this question, EMF or the total voltage or potential difference of the circuit is given, which is 12 volt, and these 2 lamps are identical. That means they will have the same electrical properties, and the potential difference or voltage dropped across each lamp is given, that is 3 volt. Since both the lamps are parallel, definitely the voltage across these lamps will be same, and that is 3.5 volt, and a current is passing through the lamp, that is 2 ampere. So there is a current of 2 ampere is passing through both the lamps. These are the informations given, and we need to calculate the resistance of this wire kept between P and Q. So this is actually a very easy question. We can focus on the wire kept between P and Q. In order to know the resistance of this wire, we can just check what is the value of voltage or potential difference across this wire, and how much current is passing through this wire. So if you know the voltage across the wire and the current across the wire, we can use the equation V is equal to IR in order to calculate resistance R. So first we can see what is the voltage drop across PQ, and it's already mentioned in the question. The total voltage produced for the whole circuit is 12 voltage, that is the EMF. Out of 12 voltage across this parallel combination, the total voltage using is 3 volt, because for parallel combination the components will be using the same voltage. So across this both parallel combination, the voltage is 3 volt. So out of 12 volt, 3 voltage is consumed by this parallel combination. This is the most important thing you should understand, that the out of 12 volt, 3 volt is consumed across this parallel combination. So the remaining voltage will be consumed by the wire PQ. So out of 12, 3 volt is consumed. So the remaining is 9 volt. So that is the voltage dropped across the wire. Now we can check the current passing through it. So this current will be actually the sum of the current passing through the lamp 1 and lamp 2. As you can see, the current from the cell will pass through this wire in this direction from positive side of the cell. Once it reaches at this parallel combination, it will split. And as it's already mentioned that both the lamps are identical, same amount of current will be flowing, and it's already mentioned that 2 ampere current is flowing. So we should know that here it must be a 4 ampere current. That's why the current is splitting equally into 2 and 2. So the total sum should be 4. So there must be a 4 ampere current flowing through this wire. So now we have the voltage across this wire in between P and Q is 9 volts, and the current must be the sum of the current passing through both the lamps. So that should be 4 ampere. As we have voltage and current, we can calculate resistance using the equation V is equal to IR. We can substitute the values. 9 is equal to 4 times R, where R is the unknown. So we can make R as the subject. So we will get R is equal to 9 over 4. And the answer is 2.25. So in 2SF it is 2.2 ohm. So the correct answer is 2.2 ohm. Please note that this is a 3-mark question, so you should write enough steps. First mark you will get for mentioning this equation V is equal to IR, and for identifying what is the voltage across the wire and the current passing through the wire, you will get the 2nd mark. And for the final answer in 2 significant figure with the correct unit, you will get the 3rd mark. Part 2. Another piece of wire is made of the same metal as PQ. The length of the new piece of wire is twice the length of PQ. So the length is double than the previous wire. The diameter of the new piece of wire is twice the diameter of PQ. So even the diameter is also doubled in the new wire. Calculate the resistance of the new piece of wire. In order to know what will happen to the new resistance of the new wire, which has the double the length and double the diameter, we need to look at the equation of resistance or how the resistance of wire relates. And we know that resistance of wire is proportional to the length but inversely proportional to the area of cross section. Or we can write length over the equation of area of cross section is pi r square. But in this question R is not given, R is radius, but instead of radius diameter is given. So we can even change this relation where R, that is radius of the wire, I am going to change into diameter, and we know that resistance is nothing but half of diameter. So I am just going to replace radius and going to write in terms of diameter, because in question they have mentioned about diameter. So the same relation I will get length, so here it will be, instead of radius I can write radius is r diameter over 2 times all square. So the same one I can write length over pi. I am opening the bracket or squaring this d over 2. So I will get d square over 2 square is 4. Now I can take this 4 to the numerator. That is a basic math. So when you use that, the 4 will go to the numerator. So we will get 4 at the numerator, 4L over pi d square. So this is actually the resistance of the first wire equation, 4L over pi d square. This is the relation, and this is actually is equal to 4 or times resistivity. There is when we are converting to equal, we will have resistivity. So this is actually 2.2. We have already calculated the resistance, 2.2 ohm. So I am just writing the resistance of the wire PQ. That equation we have learned, rho L by A, one of the very important equation. but the same equation in terms of diameter when we are writing, we will get 4L over pi d square times resistivity, and this value we have already calculated the resistance, that is 2.2 ohm. But now this same wire, the same material, so we have a new wire but with same material. So same material means resistivity rho will be same, but there are some changes happen. That is, the length of the new wire is 2 times the length of the old wire. Likewise, the diameter of the new wire is 2 times the diameter of the old wire. In this case, what will happen to new resistance? So in order to know this, we can use this relation. Okay, so we have for new wire, we know the equation is 4 times length, but the length here it is doubled. So instead of L, you should write 2L over pi will be same constant, and instead of d square, the new d again changed. That is, now the d is 2d. As we have seen, that new diameter is 2 times greater than the old diameter. So instead of new d, I can write 2d, that is the old diameter, but it's d square. So I have to square this 2d whole square times resistance is equal to so when we open, we will get, for the same relation, 4 times 2L over pi times, when you open this bracket, we will get 2 square, that is 4d square times resistivity. Now I am going to combine or write together only these terms, 4L resistivity pi d square, because that are the same things you can see in this equation. So when I write all together, I will get 4L over pi d square times density. Then the remaining things are, not density, resistivity. Then the remaining things are, as you can see, 2 over 4. So that I am going to write at the end 2 over 4. Now you can see in the case of first wire, we had already concluded 4L over pi d square by rho value is 2.2. So you can substitute that here. The value 2.2 you can substitute here. So you will get, instead of this term, you can write 2.2. So that will be 2.2 times 2 over 4 is remaining there. That is nothing but 1.1 ohm. So that is the new resistance value. Question 8, part A. State the difference between an analog signal and a digital signal. You may draw a diagram to help explain your answer. So basically, a digital signal is a signal which will have only two values, 1 and 0. But an analog signal is a signal which can have any value. That is the important difference between digital and analog signal. So we can draw one analog signal as it is having continuous or different values for different time. This is an example of analog signal. But a digital signal will only have two values, 0 or 1, or low or high. Now it's high, again going back to low, then high, or two highs, then low, then again high, low, like this. So these lows represent zeros and highs represent 1. So you can see there a digital signal will only have either zeros or 1. So this is how we can express, but we need to explain the difference. So we can start with digital signal. Digital signals have only two states, 0 or 1, or even you can write low or high. But an analog signal can have any value. That means if this point represents 0, this will be 0.1, 0.2, this will be 1, this will be again 0, this is minus 0.1. Likewise, we can represent any values in an analog signal. So that is the main difference. Since it is 2-mark question, these 2 points are enough. Part B, draw the symbol for a NOR gate. So this is an easy question. We need to draw a NOR gate. We'll have 2 inputs and 1 output. So this is a NOR gate. Part C. Figure 8.1 shows a combination of logic gates X, Y and Z. The gates are not represented by the standard symbols. So we have basically 3 logic gates. It can be any logic gates, and, or, nor, not, which is not mentioned in the question. Table 8.1 shows a partially completed truth table for this combination of logic gates. From table 8.1, deduce the name of logic gate X. So we have to check the logic gate X and its truth table and find out which logic gate it is. So we can see for logic gate X, it has 2 inputs and 1 output. Input is A, B and output is D. So we can see for AB input, what is the value of output D is getting. So this is one input of logic gate X, another input of logic gate X, and the output we are getting at D. So which truth table or which gate will give us a truth table like this? That means when both the inputs are 0, the output should be 0. Even one of the input is 0 also, the output is 0, but only we will get in one output when both inputs are 1. That means if we draw the truth table for this logic gate X, we can see different combinations of inputs. We are getting the output like this. So this is the truth table of the logic gate X, and we can identify this is a truth table of an AND gate. So this must be an AND gate. X must be an AND gate. Therefore we can write the name of the logic gate X is an AND gate. Next one, the name of logic gate Y. So we can again look at the figure. Now we need to check the logic gate Y. For this logic gate, we can check the inputs where D values are one of the input and C is the other input, and output is E. So we can see the truth table again that D and C are the inputs here. So these C and D are the inputs and output of logic gate Y is. So this is the output. That means for Y we have inputs values, 2 inputs and 1 output, where when the input values are 0, 0, this combination we can see output is 0. Likewise, when the input combination is 1, 0, the output is 1. When the input combination is 1, 1, again the output is 1. So this is the truth table of logic gate Y, and we can see this is a truth table of a OR gate. So the Y must be a OR gate. Therefore for part 1 Question 2, we can answer the name of logic gate. Why it must be a OR gate. Part 2, logic gate Z is a NAND gate. Complete the column F of table 8.1. So again we can go back to the circuit diagram, and it's mentioned that logic gate C is a NAND gate. So we should check what should be the outputs. So for this we should know the truth table of NAND gate. So for a NAND gate, it's just opposite of the AND gate output. So when the inputs are at different combination, for these values the output will be 1 1 1, and when both inputs are 1, the output will be 0. So this is the truth table of a NAND gate. Now we can fill the column F by looking at the inputs, that is E is connecting at both the inputs. So for first combination, E value is 0. That means at both inputs both input the value is 0. So this will be the combination. As you can see, when E is 0, it is exactly connecting to both the inputs. So both input will be 0. Now we can look at the truth table, that when both the inputs are 0, we can see the output will be 1. So we should write 1 as the output. Again for the second combination, 0 is at E. That means both input value will be C. So same as the first combination. So we will again get 1. So we can see whenever there is 0 at E, the output must be 1. So we can fill these rows first. Then we can check the other possible input, that is when the E value is 1. So when the E value is 1, the same input values are connecting at both ends. So the both input will be 1. So when both inputs are 1, the output will be 0. So from this we can understand when the E value is 1, both the inputs will be 1. So that the output will be, for 1 and 1, the output is 0. So the correct answer here, it will be 0 value at F. So for all E's where value is 1, we can 0 as the result. So this must be the values we should get at the output F for a NAND gate input. Question number 9. Part A. An X-ray machine requires a supply of 110 kilovolt. The main electricity supply is 230 volt. A transformer is used to supply the correct voltage to the X-ray machine. There are 50 turns on the primary coil of the transformer. Calculate the number of turns on the secondary coil. So in order to work a X-ray machine, we need to supply a 110 kilovolt of voltage, but the electricity supply only provide a voltage of 230 volt. So we need to use a transformer in order to step up the voltage from 230 volt to 110 kilovolt. So we should use a step up transformer here, where the primary voltage or the voltage available at the input terminal of the transformer, that is represented by voltage at primary, is 230, and output of the transformer, that is a voltage at secondary, is 110 kilovolt. Then number of turns in the primary is given, that is we can represent it with NS, and we need to calculate, number of turns at primary is represented by NP, and we need to calculate NS, number of turns at the secondary. So here we can use the equation NS by NP is equal to Vs by Vp. So we can substitute the values which we have. We have the value of Vs, Vp and Np. So we can substitute. So first I am rearranging the equation as I need to calculate Ns. That is the unknown value. I am keeping Ns at the LHS of the equation. And Vs over Vp is already at the RHS. And I am taking Np to the other side. So I will get the new equation like this. Now I can substitute the values. Ns, that is the turns at secondary, is Vs, which value is 110 kilovolt. Kilo means 10 to the power 3 over Vp is 230 times Np, number of turns in primary is 50. And the answer is 24,000. So the number of turns 24,000. Since it is a number, there is no unit for it. Part B, draw a label diagram of a step-down transformer. On the label, state a suitable material for each of the components. So here we need a step-down transformer. That means the number of turns at the output terminal or secondary terminals should be less. So first we can draw a soft iron core. You should draw with a ruler and a pencil. And you need to draw the coils at primary, and it must be more as it's a step down. At the secondary, the number of coils should be less comparing to the number of coils at the primary. Now you can label this as soft iron core. These are copper coil. And which is the primary at primary. And this is also copper coil but less number of turns, and this is at secondary. Since it is a question with remark, this much information about the figure is enough. Part C, explain how a transformer operates. So we can start with, we should apply a AC current at the primary. So this AC current at the primary will cause a alternating magnetic field in the core. This alternating magnetic field will cause another induced EMF in the secondary coils. These are the basic points about the working of a transformer. We can write step by step in order to score full mark. So we can write alternating voltage or AC current in the primary coil produces an alternating magnetic field in the core, which will cause an induced voltage or induced EMF in the secondary coil. Therefore, we can write which results this change in magnetic field results an induced voltage, or you can write induced EMF at the secondary coil. These points are enough in order to score 3 marks, and this is one of the very important question you can expect from the transformer. Question 10, part A. Figure 10.1 shows a beam of radiation in a vacuum. The beam contains alpha particles, beta particles and gamma rays. The beam enters a region where there is a strong uniform magnetic field. The direction of the magnetic field is out of the page. On figure 10.1, mark and label the path through the magnetic field of alpha particle. Label this with alpha. Beta particles, label with it with beta, and gamma rays, label this with gamma. So in this question, there is a beam of radiation is passing, and this radiation consists of all particles like alpha particle, beta particle and gamma rays. And when this radiation is passing through a magnetic field, in this region there is a strong magnetic field, what will happen to the paths of these radiations? Will they deviate or they will move straight? So this is what we need to know. So initially it's mentioned that the magnetic field is out of the page. That means the fields are moving outwards or facing towards us. Now we can see what will happen to the alpha particles. In order to check the direction of the movement of alpha particle in a magnetic field, we can use Fleming's left hand rule. Here we have to use our left hand and the first three fingers. The first finger, that is the thumb, should point about the force, and here we are going to find in which direction there will be force acting. So in that direction that alpha particle will move. So the thumb direction is the unknown direction here. And the second finger, that is the index finger, will represent the direction of magnetic field. And we already know in the question it's mentioned this is out of the plane. That means you should point your index finger or the second finger of your left hand pointing towards your face. That means out of the page. And the third finger or the middle finger, that should represent the flow of current or flow of alpha particle, and which we know that which is actually moving from left to right. Initially the path alpha particle or all the beams are moving towards right. So we can point the second finger and third finger according to this direction. That is, second finger, the magnetic field should be out of the plane or towards your face, and the third finger or middle finger should face towards right. So when you point these two fingers, second and third finger, according to this direction, you can see the thumb, that is the first finger, is pointing downwards. That means the alpha particle will experience a downward force. Because of that, alpha particles cannot move straight, but it will move downward as a circular path. So this will be the direction of the alpha particle. So we can label it as alpha. Now we can check what will happen to the beta particle, how it will change its direction. So in order to check the beta particle's direction, we can again use Fleming's left hand rule, where again we need to check what will happen to the force. So we need to identify in which direction there will be a force on beta particle. In that direction the beta particle will go. And the second finger, the index finger, indicates the direction of magnetic field, and it is same, that is out of the plane. So you should point your second finger or the index finger out of the plane or out of the paper, or it should point towards your face. But in the case of beta particle, it is just opposite of alpha particle, or we should consider beta particle sign is negative, which is just opposite of the alpha particle. So beta particle here is a negatively charged particle. So for a negatively charged particle, if it is moving from left to right, here we can see the beta particle is moving towards right, but as the negative particle is moving towards right, we should consider the current I, which is moving towards left, or which will be the opposite direction of the negatively charged particles. Because of that, the direction of the third finger or the middle finger, you should point towards left. That is a very important point. You should know that as beta particles are just opposite of alpha particles, or beta particles are just negatively charged particles, they will always consider just opposite direction of the current flow. And when you use Fleming's left hand rule, current flow direction indicates the third finger. So the beta particles direction we have to take just the opposite of current flow. So the third finger you should point towards left, just the opposite direction of the flow of beta particle. Now you can point your left hand according to this direction, that is the second finger out of the plane, which indicates the magnetic field direction, and the third finger should be pointing towards the left of the paper. Therefore we can see the thumb pointing upwards, so the beta particles will be moving upwards. And the last radiation is gamma rays, and gamma rays is simply a ray. It has no charge, so that it won't deviate and it will move straight. So the gamma rays will continue to move in a straight line. Part B. Radioactive sources have many uses in medicine. State 2 safety precautions which hospital staff take when working with gamma ray sources. So the first safety procedure the hospital staff should take is to stand as far as possible from the gamma ray sources, or stand behind a shield and store these gamma ray sources in a lead lined box. One additional point you can write. For this question only 2 points are enough, but still it's good to learn one more point. Limit the exposure time. Part C. The radioactive isotope iodine-131 is used as a tracer in medical diagnosis. A nucleus of iodine-131 contains 53 protons and 78 neutrons. The symbol for iodine is I. Use nuclide notation to show this isotope of iodine. So in order to represent the notation, we should write the symbol of iodine first. Then bottom left side, we should write the number of protons. And it is 53. Likewise, at the top of the left side of the symbol, we should write the mass number. That is the sum of the number of protons plus number of neutrons. So actually that is 53 plus 78, and that is 131. So you can write, or you can express a nuclide, represent a nuclide with 53 and 131. So this should be the answer. Part 2. Iodine-131 emits gamma radiation. It has a half-life of 8 hours. Explain why this emission and this half-life make iodine-131 a suitable material for a tracer in medical diagnosis. So for the medical diagnosis, one of the most using radiation is gamma radiation, and the reason is its half-life is 8 hours. So we need to explain why this 8 hours we can consider something suitable for the diagnosis process. The first point we can write, we need a long enough half-life to be detected or to reach the parts of the body required. But we should not have some radiation which has a long period half-life, then it should stay longer inside the body. That will also be dangerous. So the half-life of this substance which we are using should not have a short half-life, then we won't get enough time to diagnose the disease. At the same time, it should not have a too long half-life, then if even after the treatment still it will remain inside the body, that will also dangerous. So 8 hours is something which is very suitable. So the first point we can write, needs long enough half-life to be detected correctly. At the same time, it should not be too long. So we can write the additional point, needs short enough half-life to soon have very little activity. That means even after the diagnosis process, it won't stay inside the body. And another property of gamma is weakly ionizing, or it will pass out of the body without harm comparing to other radiations. So we can write gamma weakly ionizing or pass out of the body without harm. Thank you for watching the video. If you like this video, please subscribe my channel and like this video. Thank you.